In this video, we'll take a look at a test setup for making critical measurements and optimizing the efficiency of your converter or inverter power performance. We'll be looking at both input and output power. We'll look at the efficiency, and we'll dive into some component level losses, including switching, conduction, and magnetic losses. We'll be using an AC to DC converter demo board for the example in this video series, but these measurements apply to pretty much all power converters, including AC to DC, DC to DC, and DC to AC inverters. Let's start at the input of our AC to DC converter, where testing power quality is critical. This involves looking at input power, input ripple, reactive power, apparent power, power factor, crest factor, as well as harmonics. We have two choices here, either using a high-resolution scope such as the MSO4 series, with appropriate differential probes such as the TMDP0200 and a current probe like the TCP0030A, or using a dedicated power analyzer such as a PA1000 or a PA3000. The choice between using a scope setup versus a power analyzer usually depends on the accuracy of the required measurements. For general design and debugging, a scope setup with our power software works great, as it gives you high visibility into the signals and a lot of information in case you need to debug issues. But where compliance is concerned, or you need more accuracy for your documentation, a power analyzer is really your only option. The power software on our scope emulates the measurements of a traditional power analyzer, but makes it more convenient as a choice in the design or debug phase. Scopes and probes are great for convenience, but a scope probe channel is usually close to 1 to 2% spec accuracy, as compared to a 0.05% accuracy on a traditional power analyzer. Looking at our DC output, we have our 2380 electronic load, so we can control the load precisely for all real-world conditions. We have a couple of choices for output voltage and power measurements as well. It's convenient to just look at the numbers on an electronic load screen, but usually that won't afford the accuracy you need on the output DC measurements, especially where ripple information and load or line regulation is important. A better way is to use a high-resolution 6.5-digit DMM that affords you the resolution to accurately measure the output DC voltage quality, along with all the ripple information, as you can see on the screen. Now that we've gone over a lab setup for making some critical measurements in our converter, let's move into a more specific case where we're looking at some switching and magnetic losses measurements.